G'day and welcome to the second video on systems of linear equations. This video will be a short video looking at solving simultaneous equations, linear equations using matrices by hand. The previous video we looked at it in a calculator, how to solve them on a calculator. This time we're going to do that by hand. Now, in all honesty, you probably don't need to know this thoroughly. But you just do need to be aware of that you can actually do this, and there's a particular thing that I want to have a look at that will help us for other videos. So let me just get straight down into it. This system of linear equations here, 2x plus 5y equals 11, and the other one, that can be put into a matrix as before. And what we're going to do is we're actually going to try and undo this whole equation to just have x and y on this side, and it equaling just two numbers on this side, whatever x and y equal. They're not zeros, they're numbers. So we're not sure what they're going to be. Put a box. We're going to find out what x and y are. But you can't, it's not as simple as just dividing both sides by this matrix here. You actually need to do the inverse of this matrix to eliminate it from this side. So that's what we're going to do. You can have a look through your notes and I'll sort of talk you through them. So if we let P equal that matrix there, if we want to undo P, we can actually get the inverse of P. This is kind of like times and divide. If you times something by 2 and divide something by 2, you'll get, just 1. You'll just get, you'll sort of get rid of it. So we're actually going to get the inverse of P, the inverse of this matrix here, and if we get the inverse of this matrix, then on both sides we can actually get rid of this matrix here. Okay, so here we can say that if we get the inverse of P, the P's will kind of disappear, this one will disappear, and that means we also need to get the inverse of, like multiply that on the other side until we get that. The way to get the inverse of a matrix is a little bit tricky, and you don't really need to know why, you just kind of need to know how it's done. So to get the inverse of a matrix, you need to do two things. You need to work out the determinant, which I'll talk about in just a second, and you also need to modify the matrix. So if we have a matrix of, say, A, B, C, no, I'll change that and make it A, B, C, D. The inverse matrix will be you swap D and A, and you make B negative and C negative. I don't really want to get into why, but if you multiply those two together, you'll get the identity matrix, which is sort of what we're after. But for our intents and purposes, you just need to know that you swap those two numbers there, and you make this number negative and this number negative. So that's to work out the matrix. The inverse matrix, so that's to work out this part of the inverse matrix. The other thing we need is the determinant, this number out the front. And the way to work out the determinant is 1 over AD minus BC. So I guess for us, when we're doing this matrix, we can go, these two numbers are the same anyway, so we're going to swap 2 and 2, but they're going to be identical, and we're going to make that 5 negative down here and that 3 negative 3 positive, and we're also going to get the determinant. I'll just write that over here, we'll need this later. So determinant, I don't even know how to spell it, but whatever. It's 1 over AD, so 2 times 2, which is 4, minus 5 times negative 3, which turns out to be 1 on 19. Okay, so that's the inverse. All of that there is the inverse. Okay. Now what we do is if we want to get rid of the matrix on the left hand side, this one here, we need to multiply it by the inverse. If we do that, it will disappear altogether, and then we also need to multiply the other side by the inverse as well. So that's what this line is just here. We multiply this side by the inverse to get rid of the original matrix, and we multiply this side by the inverse as well, and we multiply by 11 and 12. And once we've done all that, there's two ways of doing this, but probably the easiest way is to do 2 times 11, which is 22, plus 5 times 12, or negative 5 times 12 is negative 60. That's the top number. And then 3 times 11, which is 33, and plus 2 times 12, which is 24, and then all of that is multiplied by 1 on 19. So then when we add those two together and divide by 19, we'll get -2. And when we add those two together and divide by 19, or so multiply by 1 on 19, we'll get the answer of 3. And that's how we get the inverse matrix. Again, you don't need to know all the ins and outs of that sort of thing. Just have a go at a couple of questions just to get the hang of it. The thing that we really need to know from all of this is the determinant, which I will talk about in just a little bit. But the next video will be on the three types of simultaneous equations that we can encounter when we've got linear graphs, but this is how to solve simultaneous equations. So thanks for watching.